Hi everyone, I'm going to talk about scientific advancement, which is simply how humans change the world. It's the way that we make all the discoveries that we make. It's the method that we use. In fact, that's why we call it the scientific method. So, problem or solution? What do I mean by this? Well, since we evolved on the planet, we have made many changes to the environment, and not all of them have been good. We talked about this when we did environmental science in M2. So the question we ask ourselves is, all of this amazing brain power that allows us to do science, is it really a good thing? Does it solve problems for us, or does it make more? Well, our ability to change the environment is what has made us the most successful species on the planet by some measures. We may not be the most successful in population. There are far more chickens than people and far more bacteria than chickens. But we can make machines and other complex designs like medicines and art, and so our lives are very different to other animals, and we control the environment in many ways. So how do we change the world? We've established that humans can change the world for good or for bad, but how exactly do we do it? Well, we're going to start with a story, and if you think you're a little too old for stories, then just bear with me here. So once upon a time, maybe a caveman was walking along through his caveman world, and he saw something surprising. He saw a coconut breaking on a rock, and this fact gave him something of an idea. And that idea was coconut plus rock equals food. So after this, the caveman got excited and thought about how he could get into coconuts more easily. He tried a number of things. He tried dropping them on rocks, he tried dropping them from cliffs, hitting them with things like bananas and other rocks. And then eventually he found that all of these things that he tried did actually work, except for bananas, of course. But he found that it worked best if you hit the coconut with a rock while it sat on another rock. So here, the caveman has found his final successful design. He looked at putting the coconut on a rock and hitting it, and he decided that this was the best way to go about it. So after that, he decided to show all of his friends, and of course, everyone was amazed by this new way to get food. So the caveman had discovered a very simple hammer, and he'd also understood a very simple scientific principle about how objects move, about the way heavy objects create a force when they move. So how did he do this? Well, what he did was use, in his caveman brain, something that we still use today in a slightly different way. The answer is scientific method. So the basic scientific method is the same as it has always been, but what we have done is make it more formal and make it even more precise. So what is the scientific method? Well, I'm going to put it as a very simple 5-stage process. Stage 1 is ask a question or make a hypothesis. A hypothesis is like a guess. Stage 2, do research, find background information about the subject, look at what other people have done in this area already. Stage 3, design and do an experiment, a test that will answer your question for you. Stage 4, look at the results, analyze your data. And then stage 5 is tell others about it, report back so that other people can benefit from your experience. You may see the scientific method written in different ways with a few more or a few less parts in it, but it will always follow this basic form. After you've finished any experiment, you may find there's more follow-up work to be done. There may be other things you need to try or problems you need to fix. So when asking a question or making a hypothesis, what you're really doing is understanding something that you don't currently have any way to understand. So you need to find a way to do this. A hypothesis, for example, is a working guess, and an example about the hypothesis would be more people have fried rice in the canteen at lunchtime. So you're suggesting that of all the food in the canteen, fried rice sells the best at lunchtime. And then you have to go and see if that's true or if it's false. So a hypothesis can be true or false. Asking a question, on the other hand, that asks for unknown facts. So, for example, which meal do most people eat in the canteen at lunchtime? So you simply ask and then go and find a way to answer that question. And as you can see, that really amounts to exactly the same thing. So how did the caveman go about making a hypothesis? Well, he could have asked a question like, how did the coconut break? Or alternatively, he could have put it in a hypothesis form like, the coconut broke because of the rock. He's stating what he thinks and then he proves it true or false. That's how a hypothesis works. So the second stage is to do research, and really when you do research you are finding out what is already known by other people. So you're going to need to look at other people's work and you're going to need to find out what they know already so that you don't reinvent the wheel. If you do something amazing and you work really hard but somebody else did it 3 years ago, then you didn't do anything really very important at all, did you? So for the caveman, research was easy. This was the first time anyone had done this, and all his research was done by just looking at the world and thinking about what he knows. These days, of course, all science subjects have thousands of pages written about them. Papers, reports, books, and research therefore has become very important to do and very important to get right. So how did the caveman go about doing research? Well, there were no books for him to read, so he just thought about what he knew about the world around him. He collected facts. He knows the rock is hard, he knows the coconut fell fast, he knew that it hit a rock and that the coconut broke. And so that's his evidence, and that would lead him to maybe asking some follow-up questions. And these are the sort of questions that would help him design a test to work out what is actually happening. And do hard things make coconuts break? Does the coconut need to be moving fast? Can you hit it with anything? A banana, maybe? Step 3 is design and do an experiment. You have your questions, you have your research. Now you can start to solve your hypothesis, but you need to design the right sort of test. You need to make sure that your results answer your question. How do you do that? Well, again, for the caveman, this was very easy. His experiments were simple, but scientists today have to think a lot about variables. The caveman was thinking about variables too, but he didn't have to think of them quite so carefully. But variables are simply what changes and what stays the same in a science experiment. So how did the caveman design an experiment? Well, he just came up with some test scenarios, some things that he would do to simulate the idea of a coconut falling from a tree onto a rock. He tried small rocks and big rocks, rocks and bananas, dropping them from cliffs and putting them on other rocks. These are all supposed to, in some way, get at something about what he saw when the coconut fell onto the rock. So the fourth step is to look at the results and analyse the data. At the end of the experiment, you're going to have collected a lot of information, and this is your data, and it might be numbers or it might be observations that you saw when you were doing the experiment. But either way, now you have to analyse your data, look at it and decide what it tells you. This was easy for the caveman, of course. All he had to do was answer a simple question. Did the coconut break? Yes or no? For today's scientists, analysis can take months or even years with the most powerful computers. In some ways, it's still about the same thing as the caveman's experiment, though. The scientist would be asking, did I see what I expected to see in the experiment? And whether it's a yes or a no will send them in a different direction in their future experiments. So as we keep saying, of course, for the caveman, analysing was very easy. I could open the coconut with rocks, I could not open it with bananas. Simple. That was his general observation. Rocks worked, bananas didn't. Then of course he had his best way, his top tip if you like. The easiest way to open the coconut was to put it on another rock first. So that was his specific observation. So 5. Tell others your findings. Report back. So it's important to communicate your findings when you do science, because it doesn't matter if what you found is what you expected to find. other people might want to use the information. They can use your data and do further experiments to either back up your true finding or to find out the truth if your experiment went good or bad. If your experiment was good, they can go further and make more discoveries. And if your experiment was bad, you can still report on where you went wrong and other scientists can learn from the mistakes. So, of course, we saw the caveman reporting back to his friends. Not much peer review, he didn't have to write any big reports, so, as always, Mr. Caveman gets an easy ride. So the story continues. The caveman and the coconut was just the beginning. Other people were making discoveries in exactly the same way, and they've been making them ever since. Maybe another caveman cut himself while climbing on a rock, and he realized that if you have a small rock that is sharp, you can use it for cutting things, and he invented a knife. Maybe someone else realized you could use the knife to cut the skin off animals to make clothes and bags. Maybe someone else found if you attach a knife to a stick, then you have a spear that you can use to kill things without getting close. So everyone is building on the discoveries of the previous generation, and every tiny thing we discover is found because we use that same process. Ask, investigate, analyze, and report. And of course, there are large numbers of people we could use as examples. We're just going to look at a few of them now. So, the ancient scientists, two of the most famous ones were the Greeks Pythagoras and Archimedes, but Greece was not the only scientific culture around at that time. The Chinese, the Middle Americans, and others were making similar advances in mathematics and science. Pythagoras invented a formula that we still use in school today, the formula for right-angled triangles, and Archimedes was the first to discover the principles behind liquid displacement, the way that boats float, and it also allowed him to find out that the crown that was given to his king was in fact a fake made of lead. So a formal beginning could have come with Galileo Galilei. He's commonly talked about as one of the first people to use the method as we understand it today. He was certainly not the very first. He was preceded by maybe 100 years on that score, but he was one of the most brilliant scientists of the age, combining experiment and record keeping to lay the foundation for many scientists who came after him. So then came the Renaissance, which means rebirth. And the Renaissance is a particularly European phenomenon, as you can tell by the French name. It's the time from 1500 to 1700 approximately, and there was a new interest in the Greek tradition of discovery, and there were many important scientific discoveries. Isaac Newton, I'm sure needs no introduction. You've probably all heard of him, one of the most famous and influential scientists of all time. And just before him came Johannes Kepler, who discovered the laws that control the movement of the planets around the sun. And Newton even used Kepler's information when years later he came to invent a new kind of mathematics. Now, Kepler was a great theorist, but unfortunately he didn't have the equipment or the resources to take the data, so he needed an experimentalist, which he found in Tycho Brahe, and these two men working together were able to solve the problem that neither one of them could do alone. So, moving into the modern era, everyone has heard of Einstein, of course, but he was not the only famous scientist. There was Niels Bohr, who was in many ways the first particle physicist, or one of the first, and he also was in the team that designed the atomic bomb. Not a great legacy, but it shows what a brilliant scientist he was. And then Lise Meitner, who was a female scientist who did many things in the field of radiation. You may have heard of Marie Curie. Lise Meitner not so much, because she was kind of overlooked by history, and it was her male colleagues who won prizes. And it was actually her who had done most of the work and made most of the discoveries. And then there's the Nobel Prize. There is Nobel Prizes for a number of things, but in science there are two, and it's a very famous prize. These are last year's winners in 2014. The Chemistry Prize went to three gentlemen who invented super-resolved fluorescence microscopy, which I think is trying to see things which are smaller than light. If you think about that for a minute, it might start to bend your mind a little. Light bouncing off things is how we see everything. how do we see things that are smaller than light? Well, we use super resolve fluorescence microscopy, of course. And then there's these three guys who invented the blue light-emitting diodes, winning them the Nobel Prize for Physics. So, you may remember a few years ago we only had red and green LEDs on our equipment, and then one day we started to get stereos and iPods with blue LEDs on, and didn't they look beautiful? And of course they were so beautiful they gave these three men a Nobel Prize. No, it's not quite that simple. You see, with blue LEDs, we'd finally got a set of primary colours. We had red, green and blue, the same ones that you see on your TV tube set, which means now finally we could create white LED light. And this is a huge deal because LEDs are much cheaper to manufacture and run than regular light bulbs. So finally being able to create white LED light means it's now much cheaper to actually just light the world. And so that's why these guys were worthy of a Nobel Prize. So remember, all these scientists had good ideas and they followed them up with good scientific method. And if you want to be one of the next generation of famous scientists, you're going to need to do the same. So all the skills of scientific method, though, can help you in everyday problem solving. It's all just planning, analysis, judgment. Every problem in life is solved by using these techniques. So keep this in mind when you come to design your project or in any other problem you face.